In this video, we'll continue to go over some topics from Chapter 2, in particular, measures of relative standing and box plots. So the basic idea is to, when you have a data set, sometimes you want to compare how one value is related to another value, or also if we have different data sets, to compare values between different related data sets. So here, what we can do is we can use something called the z-score, which relates a value. So it describes how a value is related to the mean and the standard deviation. So basically, the z-score tells you how far a value is above or below the mean in terms of the number of standard deviations it is in terms of distance, right? So a z-score of +1 would mean that it's one standard deviation distance away from the mean in the positive direction. A value of -1 would mean it's one standard deviation distance away in the negative direction. +2 would mean that it's 2 standard deviations away in the positive direction, and so on. So the farther, so typically values that are fairly close to the standard deviation, so with a z-score between -2 and 2, are considered typical values, and values that are much farther away, so more than 2 standard deviations away from the mean, are considered unusual values. Okay, so let's take a look at an example where we calculate a z-score and sort of interpret what that means in terms of the data set. So in example 1, we are given that adult men have heights with a mean of 69 inches and a standard deviation of 2.8 inches, right? So here, let's assume that this is the population of adult men. So the mean will be mu for the population mean, so that's 69, and the standard deviation would be sigma, which is 2.8. And we want to calculate the z-score for a man who is 63.3 inches tall, right? So this is a particular value, so x would be 63.3. So if I want to calculate the z-score, the formula is x minus mu over sigma. So again, I put the parentheses in the numerator like this so that when I calculate, the calculator understands the order of operations. Okay, so let's calculate. 63.3 minus 69 divided by 2.8. And we get a z-score of -2.0357. And you can see that this is farther away than -2, so this is considered an unusual value. Sorry, so this is less than -2, so this is an unusual value. What this means is that this person who's 63.3 inches tall is a little bit shorter than the typical person who should fall within this range of z-scores. So it's somewhat rare to have a person who's this height. Okay, so that's the z-score. So next we're going to discuss box plots, which is another way of organizing data. And so what the box plot essentially does is it divides a data set into 4 groups, so essentially quarters, where so like the minimum value would be at the left end, the maximum value would be at the right end, and then if you arrange all the data points in between, 25% of them will fall in the first quarter, then another 25% will fall within the second quarter, another 25% will fall in the third quarter, and then another 25% will fall in the last quarter. And so the values that separate these group of data points, so you have the minimum all the way at the left end. Q1 is called the first quartile, right? So it separates this 25% from the rest of the data. The median, also called the second quartile, here is the exact middle point where half of the data is to the left, half the data is to the right. And then Q3 is called the third quartile, and it separates the bottom 75% from the top 25%. So this is the information described in a box plot. And then some things you can calculate related to this is so a few different types of spread, right? So the interquartile range is sort of the spread between the spread for the middle 50%, right? So it's Q3 minus Q1. And the semi-interquartile range is just taking the interquartile range and dividing by 2. And then the mid-quartile is to take the average of Q1 and Q3. And then together, these 5 numbers, so the minimum, Q1, median, Q3, maximum, are called the 5-number summary of a data set, which we can visualize in the form of a box plot, or sometimes called a box and whisker diagram, right? So the actual data values are arranged according to where they should be in the number line. So if the value is farther away, there's a larger distance, but you just list the 5-number summary and then draw in the different parts of the box plot according to where the values occur, right? So this left tail here is where the minimum is, the right tail here is where the maximum is, and then Q1, median, and Q3 form the box in the middle of the box plot. Okay, so let's take this box plot and describe some things we can say about it. Right, so here we want to calculate the interquartile range, which is just Q3 minus Q1. And so we can just plug in the numbers and calculate, right? So Q3 is 113, Q1 is 35. So if we calculate this, we get 78. So one thing the box plot allows us to do is to visualize the data, right? So in terms of whether the distribution is symmetric, skewed left or skewed right. So like the median is a measure of center, right? So you can imagine the center of the data is around here, and here this little line on the left and the little line on the right tells us how the distribution might have a tail, right? So you can see this left side, this right side is much longer than the left side, so the tail of the distribution should be on the right side. So we say that it's skewed right. Right, so again, this would be considered a right tail on the distribution. And again, you can see sort of the spread between the values by looking at the distances between the different pieces here, right? So the quarter with the largest spread should be this here, right? Because this is the longest distance. So the largest spread is between Q3 and the maximum, which is the fourth quarter, right? Because this is the first quarter, second quarter, third quarter, and fourth quarter. So this would be the fourth quarter. And then finally, where is the 65th percentile, right? So you can see that the 4 quarters are marked off by these different values, right? So the minimum would be at 0%, right? So then Q1 would be at 25%. The median is where the 50% mark is. Q3 would be the 75% mark, and the maximum would be the 100% mark, right? So, so the 65th percentile would be somewhere between the 50% and the 75%, right? So between the median in Q3 and the median has a value of 68, and the Q3 has a value of 113. And so the box plot gives us a summary of the data, which allows us to sort of interpret the data set in this way.